All right. Thank you very much. So this will be interactive. We're asking questions basically. So we know what time series is. It's looking at observations and checking the progress over time. That's basically what it is. So as time passes, how does your variable behave? That's basically what time series is. And so I hope you can see the question. We're going to walk through this question. I think it will encompass almost everything that or most of it that you'll have in your text. So an analyst as at an asset management firm is evaluating several time series models for forecasting monthly this and that. So let's go to the model. Model one is regression, simple regression of industrial production growth versus leading economic indicator. Two is a residual model. Three is an AR1 model. Can I ask, what's your level of expertise between 1 and 5? 5 being, I'm ready to take the exam tomorrow. 1 being, man, I read everything else apart from time series. So I know how much to break down and how fast to speed up. Did I see, is that a -2? Samson, did you say -2? Okay. So 1 being the lowest, 5 means I'm good to go. No, 2.8 is enough. Give me 1, 2, 3, 4, 5, 3, 3. All right. 0. Okay, so nobody's claiming expertise on this. So we'll take it slow. 4. Alima, thank you. Okay, so we'll take it. I'll slow down. It looks like confidence levels are low on time series. So I'll slow down. Like I said, time series is tracking the observations over time. And so an AR1 model is an autoregressive model. You're checking what is the value against yesterday's. We all know what regression is, right? At least let me know we know what regression is. Yes, okay, good. So I won't bother going into that. So an AR1 model means you're regressing the current value against previous value. It means you're assuming that the value you had latest is predicting today's value. It means yesterday's value is predicting today's value. Today's value is going to predict tomorrow's value. That's what an AR model is. And that's what you're saying in model 2, that you have a YT and a YT -1. So 3 is commodity price, and then we have another AR model. So I hope you have paper and pen and a calculator next to you. If you don't, please get one now. So we're going to start. Dubbin Watson. Who remembers what that is? Do you guys remember what a Dubbin Watson is? Yes. Yes. Okay, good. So you're not so bad. So we're going to test for serial correlation. The coefficient was 0.54. Does it imply that there's a negative serial correlation, or that there's little or no, or that there's a positive correlation? That's question 1. So please, if you're responding, say 1, this is the answer. 2, this is the answer. Number 2, what is the effect of serial correlation? The primary concern associated with serial correlation and regression results is what? 1, that the coefficient estimates become inconsistent, that the standard errors and test statistics may be unreliable, or that the regression becomes unstationary. So write 1 and 2. So 1C, okay. So 2, what? 2B, 2B. Okay, faithful. Okay, so 1C. Most people got 1C, 2B. So I will not need to dwell on it. Let's keep going. Residual 3. Residual process. Epsilon is 0.7 of the lagged value plus an error term. Most likely implies that shocks, A, they dissipate gradually over time. They increase exponentially over time, or they disappear immediately after one period. Number 3, 1A, okay. 2 is 3, all right. So number 4, that's fine. Monica, what question were you referring to that you're asking about why the options are wrong? Monica, you need to tell me what number you were speaking to so I don't hold everyone else up. 2. Oh, okay. Question 2. Okay. So the effects of serial correlation. So the coefficient, there are 3 options. The coefficient estimates become inconsistent. Standard errors and test statistics may be unreliable, or the regression becomes unstationary. So serial correlation distorts standard error, basically, and the t-statistic. So that's why, okay, you get it now? Okay, all right. Okay, so let's move on. Well, number 3, and I think most people had responded with A. So let's look at number 4. The ARO model. The revised ARO model is most likely preferred because, let's go back to what the ARO model is. So we had this before. We have this. Do you see? Yes, okay, thank you. So let's go back. So the revised model is preferred. Why? It captures persistence, it eliminates forecasting error, or it guarantees covariance stationary. O is A, okay. A, okay. One more person, number 4. I need one more response, please, number 4. Okay, let me go back. Do you see? Okay. Yeah, so I'll explain 3 and 4 when I go get one more answer for number 4. Okay, so let's look at what the answers are. So 3 is A. Look at the process. You're regressing against 0.7, and it most likely means that the shock will dissipate over time. So a shock makes a time series reverting, right? It goes back to the mean. It means if it's tracking up, it will come back down. If it was tracking down, then it's going to go back up. Means it revolves around the mean somehow. So what we're looking at right now for number 3 is that coefficient of 0.7. So imagine if this was 4. It means for every time this is, if yesterday's price, for example, was 2, this would be 2 times 4, 8. Then it means today's price is 8 times 4, 32. You get, so it's going up very fast. But imagine if it was 1. It means if yesterday's price was 2, today's price will be 2. It means tomorrow's price will still be 2. You see, it hovers around the mean. That's what the shock means. So you're looking at this coefficient to say, if it is between 0 and 1, it means it will gradually, the effect will be reduced with time. It means it's increasing, but it's not increasing at a very fast pace. That's what we're looking at. So when they say shock, you're looking at this coefficient term to see how large it is. If it's between 0 and 1, it means there's an increment, but it's not a lot. If it's above 1, then we call it an explosion. It means for every one step you take between yesterday and today, there's going to be a multiplier effect. Is that understood? Okay, thank you, Isaac. So let me just run through the answers. So A says the shock dissipates gradually because that coefficient 0.7 is between 0 and 1. The process is persistent, but is mean reverting. Like I said, it will always dial back to normal. The shock will then fade geometrically. B is wrong because it will have been an explosive term, like I said. When this term is greater than 1, it means it's accelerating faster than, for every one thing, every move you make is moving very fast. And then C says it will disappear immediately after one period. That will not happen if this is not 0. So that's that. Are we good? Yes. Okay, thank you. So 4, an AR1 model, the preference, like I said, you're tracking against what happened yesterday. So yesterday's value is your predictor, as it were. And it's most likely preferred because it captures persistence. So persistence is how long the effect of the shock lasts. As in, how long does it last before it, how long does the shock stays? So including lag variables helps models. B, it eliminates all forecasting errors. That's not what we're discussing here. Nothing you do will eliminate forecasting errors. It's almost impossible. There will always be that margin of error. And C, guarantees covariance stationary. No, that doesn't happen in an AR model. It's not guaranteed. Okay, good. So I hope we're doing well so far. Let's move on to next question. So 5, the revised, let's 5. Let's go to 6. Out of sample root mean square errors. Are you guys with me? Out of sample root mean square errors. So if you compare in sample fitting measures, the lower out of sample root mean square error most likely indicates what? A, B, or C? A. So please, I appreciate if you put the question number so that we're on the same page. I have one 6A. 6A, good. Okay. Yeah, so root mean square error is how far away the predictions are from average. Are you close to where everybody else is, or are your values all over the place? So because we've already called it root mean square error, it means you want to reduce error. Okay, since everybody's saying A, should I just move on? It looks like we know this one. Because I've mentioned errors, it means you want it to be as low as possible. So if you compare in sample fitting, it means you already have that sample. And so you can use that to test how well am I doing. And then out of sample means you don't have that, is what you're forecasting, right? In sample is the data you have available, the samples that are observable as is. Out of sample means you're going into the forecasting environment. So if you have lower out of sample errors, it means your model is, I don't want to say fantastic, but it's doing well. You get that? So it means that you have superior forecasting performance. So B says lower root mean square error alone does not imply instability and does not directly diagnose seasonality. That's a different kettle of fish. Okay. So 7, the model, if you can see the model, is best. Okay. Thank you. Good predictive power. Oh, yeah. Thank you very much. But did I answer your question? Yes, thank you. Okay, so 7, the model is best described as A, B, or C. No response yet. 7B, okay. C, can I get one more? C. Okay, number 8. Unit root evidence. What's the strongest evidence that this has a unit root? Let's try 8. Number 8, please. 8B. Okay, so let's see. For 7, we had an A and we had a B. For 8, most people said B. Okay, so let's look to why some people said A and some people said B. So these questions were kind of drafted so that it will make you have to think a bit more. So if you've not been reading your text, you'll have to do a bit deep dive. So what's the difference? The model this is best described as, so first of all, what's covariance stationary? It means your mean is constant over time. B trend. Okay, thank you, Babatokwe. So you say it's covariance stationary when the mean is constant over time, when your variance is also constant, and autocovariance depends on only one lag variable. The trend analysis, the trend is slightly different. There's just one slight difference between both of them, and that's this term here, which was why this, wait, here. Can you see the highlighter? Yes. So this is the max difference between all three. For it to be covariance stationary, this has to be less than 1. Think of it, the person that said A was the answer. Covariance stationary, one of the rules is that the mean has to be constant over time. Imagine if this is 1.5. If t is 1, this is 1.5 plus 40. That's 41.5. If t is 2, this is 3 plus 40. That's 43. If this was 4, that would be 6 plus 40, 46. You see it's trending upward. It's not mean reverting. So that's what you should be checking for, to say what's the value of this coefficient here, which was why this question was crafted like this. So it's not just to see the format and say, oh yeah, it looks like it is. It's not, because this would always be upward trending. It can be mean reverting. So if it was covariance stationary, this would be less than 1. Are we good? If I should explain first, no, I think at this stage you should have read, so we should be checking what you know. If I explain, then you won't be sure whether you know it or not. So I prefer the approach of you trying to see whether you know it, as in simulating the exam conditions as it were, and then we can have an explanation at the end. Or does everyone else feel we should do an explanation first? It means I'm teaching you, or rather you test yourself to know how well or how badly you're doing. Something if that's fine. Okay, thank you, Joke. So let's do it that way, please. Exactly, Oyedamola. Let's attempt first, and then explanations will come later. If everybody gets it, then there's no point wasting time on that question. So, okay, so a stochastic trend means the path is random and the shocks are permanent. So this will not be there. This will not be there. because this 40 means you always have that constant fixed. Whatever you do, there'll always be a plus 40 on top. So when we say it's stochastic, it means it's just wandering up and down. Imagine how a fly perches all over the place, or a drunk moves around without a clear path. That's what it is. V0 is 0, yes. That's what we're speaking to. Yes. Okay, so most people got 8B. So do we need to speak to it? I think I've already mentioned it before about being close to 1 as possible. So I think we can move on. Most people got that right. Okay, number 9. Log linear growth rate. The approximate growth rate implied by natural log ST, that equation is closest to number 9, A, B, or C. 9B, okay. 9B, okay. Let's try number 10. Number 10, random, compared to the covariance stationary AR1 process, shocks to random walk most likely. Number 10, okay, everybody go 9B. 10, is that faithful? Is that 10? 10B, okay. 10B, okay. Okay, so everybody got that right, so no need to dwell on it. Well done, guys. Let's go on to 11. So number 9, what happens to number 9? Baba Tokwe. What was the issue with number 9? Everybody got it right. 9, okay. Okay, so 2 people say go back to 9. So let's touch on 9. So number 9 is speaking to log linear, right? You can see the natural log sign on this side. Baba Tokwe and Temitope, please confirm that you can see that we're not just looking at this is a log linear model. And so the approximate growth rate is closest to, we're looking at this here. This is what we're looking at. Right? But the difference now is because it's log linear, look at the explanation on this side. You always would have to find e raised to power. Okay, you understand? Oh, okay, fine. Okay, so I think it wasn't that you didn't know it, it's just that you were not paying attention to the framing of the question. So please, maybe that's a takeaway from here, outside everything else, that you will want to calm down and take your time and read the question maybe twice to be sure of what they're asking, because there's always a tendency that they will put the wrong answer there. And so if you're rushing, thinking you want to make up for time, you might be thinking you're picking the right answers. Meanwhile, you're making mistakes that were avoidable. So I've seen that happen maybe twice now. So please just read the question the second time before you pick an answer. Because obviously you guys understood. It was just that paying attention to the framing. Exactly. Thank you, Sayemi. All right. So because the explanations were not necessary, it was just that you didn't read the questions properly. So let's move on. So 11, what if you estimate this instead? This process is best described as A, B, or C. Number 11, please. 11B. Please write the number so that we know what it is. 11C, okay? C, okay. C, okay, thanks. So let's try 12. Okay, it was just one person that said B. Okay, 12. 11B. 12A. Okay. Can I get more people responding to number 12? A. Okay, thank you. So let's see. 12A is correct. 11 I will touch on because there are two different answers. I have a B and I have a C. So suppose this is what it is instead, that it is equal to beta naught is 3 and you have 1.01 and then the error term. What will you describe it as? I had said before that we're looking at this portion of it. Anything greater than 1 is said to be explosive because it means that if yesterday's value was 1, then today will be, let me just assume that is 1 instead of 1.01. It means that today's value will be 4. If today's value is 4, 4 times 1 is 4 plus 3 is 7. Then the day after will be 7 plus 3, 10. You can see it's increasing at rapid rates. It's not going to be coming back down. It's not mean reverting. It's just rambling all over the place and moving very fast. Is basically what it is. So the person that said, was it B? Do you understand why it's C? For it to be mean reverting, the coefficient has to be below 1. That's this one has to be below 1. You get it? Okay. All right. So that's I'm trying to manage time. I wanted to allot 30 minutes to each section. So that's all for time series. Let's go on to machine learning. So for machine learning, scale of 1 to 5. 1 being, oh boy, I never opened that side. 5 means I'm ready to go. Rate yourself. No shame. It's almost divided by 0. Okay. Okay. So it looks like we're a bit more confident here than in time series. But was time series okay though? If we have time, you can drop any topics you want us to touch on. We could if we can go back. But let's at least get a lay of the land on everything once. Was the time series portion okay? Yes, okay, thank you. So let's do machine learning. Fatia, tell me what sections of time series you want us to touch on. If we can, we'll go back. I will take notes of. Okay. But I'm waiting for your feedback on what you had an issue with. So for machine learning, let's keep going. Unit root and yeah, okay. Okay, so let me just touch on unit root briefly. One person asked, and then we can move on. Sorry, guys, I'll just take it back a bit. So a unit root means that the series is non-stationary. Let me go back. It's not unit. No. Okay. So it means time series is non-stationary. Let me look for. Okay. It means it's non-stationary. So that means it doesn't go back to the mean eventually. It's not mean reverting. Is what it means. And so it means it will continue moving in one funny direction. You're not sure where. And so you could have two types of that. there's one you could call a random walk. Just imagine someone who has lost his way. You keep going around in circles. There's a possibility that you might be drifting in one direction or you might be coming back. We're not quite sure what it is. So that's what the unit root implies. Okay, sorry for taking you back, guys. So number one, you said A. Everybody says A, okay? So that's A. No need to spend time on that. Number two, machine learning model designed to predict whether a company will receive an upgrade or no change or a downgrade in its credit rating. This problem is best categorized as number two. Two B. Okay. All right. You guys are not joking when you said you understood machine learning. All right. So let's move to number three. A neural network achieves 99% training accuracy, but only 58% validation accuracy. The result most likely indicates C. Okay. All right. 4. Increasing model complexity would most likely yes. Number 4. 4C, 4C, 4C. 4A. Okay, so this one now we'll spend time on this because I have equal number of A's and C's. So let's read the question together. So when you increase model complexity, means you're adding more variables and making it bigger than it should be. What happens? What's bias error, first of all? So bias error is when you oversimplify the assumptions, means you should be tracking maybe 2 or 3 or 4 variables and you're tracking only one. It means you're not going to see what the real pattern is in the data set you have. So let's say you're tracking people who are who are higher up in the organization, and you just assume it's because of age. So that's one variable. So you assume because you're 45, you should be in a higher position than someone who is 23. You don't factor in experience and maybe your degree. So someone who might be 23 might be your boss if you're 45 because the person has a PhD from Harvard, for example. Right. So if you only want to track pay versus age, then there'll be a problem. But so complexity means you start adding other variables to it to say this might also account for why this person is earning more than someone else. So it means when you increase the complexity, you're going to reduce the bias error. So what's variance error? Variance error is when the data set is too sensitive to the training data. Means it changes a lot. Right? So in this case, there has to be a trade-off. If you're increasing complexity, then you're also 4A. Okay. So if you increase the complexity, then you can have stuff all over the place. That's the problem. You might have too many. Now you're chasing too many things as it were. Instead of me to focus on maybe just age and your degree in school, I might not add your complexion or if you're a male or female, or if you're very tall, I can start adding all those kind of things. Do you dress very well or you don't? So that might be a reason why you're getting more promotion. Are you a noisemaker in the office or you're very quiet? By the time I start adding all these different variables, you will not download which one we're tracking anymore is the reason. So while it would be good to factor in more variables to say what can be the reason why people earn more than other people, overdoing it will start causing problems for you. So that's why there's that balance between the bias error and the variance. Is that clear? Zainab, thank you. Okay, so let's move on. Number 5, k-fold cross. You're welcome. K-fold cross validation is primarily used to five is B. Okay. Okay. So if anyone doesn't want to say B, would you want to say what you think the answer is? Because I'm seeing a lot of B's. Just in case there's someone who isn't typing as fast as the others that needs to read a bit longer. Okay. So the cross validation improves estimation of out of sample performance while preserving training data. So what does cross validation mean? It means you have this set of data, you break it up into a number of parts, and you say, let me use this one to test this one, and then I use this, and then I test it against the others. That's basically what it is. The analogy in my head right now is what you guys, I expect you'll be doing, that you're here solving questions. I also expect that you have the examples in the curriculum and you'll have solved through everyone. And you'll also check the end of reading questions. You try to solve everyone. And then you'll also want to do a mock. I would recommend as much as possible sticking to CFA material. I know there are a lot of materials out there now, but I would personally recommend sticking with CFA because those ones help with getting the concept. The exam is usually simpler than it is. Those guys make you read a lot more. And then when they give you the simple questions, you're wondering, you start overthinking and overanalyzing. So this is an example of what cross-validation is. Try to stick to everything CFA gives you as much as possible. Make sure you've consumed all their questions like 2 or 3 times before you start venturing out. So that's what cross-validation is. So well done, guys. 6. So thank you, sir. So regularization techniques are primarily designed to, 1, reduce model complexity, 2, maximize the number of included variables, 3, eliminate all A. I'm still saying is. Okay. So regularization basically reduces overfitting so that you don't overcomplicate things. Like I said, someone is earning more. Do you say it's because the person just is better than other people? Or you say because the person is fairer than other people? Or you say because the person, so there are different ways you could look at it and you can start overcomplicating it. It might just be as easy as the person has a mentor. I don't know how to model that though. So it's good to keep it as simple. So regularization it penalizes the model for excessive independent variables as it were. So it reduces the model to improve generalization. Okay. So a lasso regression compared with OLS, lasso is most likely to A, B, or C. Number 7. 7A, 7B, 7B. A. Okay. So LASSO stands for least absolute shrinkage and selection operator. So what it does is it has this lambda that it uses to penalize the model as it were. Like I said, if you get very excited and you start adding the variables and you have maybe 5 or 6 or 7 variables and maybe your model only needed like 2 or 3, Lasso will shrink those ones for you. It will apply a factor. So it's the absolute value, adding the absolute values together. Adding the absolute values together, and then you apply that factor. As you add the different absolute values of the betas together to get a specific value, and then you apply it to all the coefficients as it were. So those ones that have no bearing, for example, someone who is fair, it will take it out. So it penalizes the coefficient magnitude and may effectively remove weak predictors. B is wrong. B is correct. A, retain all features regardless of predicted contribution. No, that's wrong. That's exactly what it does. It shrinks those ones that are not useful out and eliminate all bias in. That's also wrong. It will introduce some form of bias. So some it shrinks. Babatokwe, I see you. Some it shrinks, some it takes out completely. So Lasso has that capacity to say it can eliminate some that are not useful at all. Any other questions? So it's slightly different from the ridge regression. That one is the one that will take it close to 0, but it's not eliminate it completely. But for Lasso, it does. Okay. So let's look at SVM. It supports vector machine classifier 6.2. A, recursively partition data into terminal nodes. B, maximize the separation margin between classes. C, reduce correlated variables. Okay. So everybody says it's B. Well done, guys. So it identifies the optimal separating hyperplane, as in how far away can we keep them so that you don't go too close to the boundary, is basically what it is. C is wrong because when we're discussing cats, we're discussing decision trees as well. And no, that's for A. C is wrong because we're discussing PCAs. That's how you transform data, segregate correlated data. So well done. Number 9. K-nearest neighbor classification determines the class of a new observation using A, distance to nearby observations, eigenvalues of covariance metrics, recursive binary partitioning. Okay, so K nearest neighbor is look at the people around you and you guys band together. Just like how they say, show me your friends and I'll tell you who you are, kind of thing. So you look for who is closest to you. Be your brother's keeper. What does B mean? So eigenvalues are like you look at a point and you see how important is it to everything else? Where is it compared to everything else? That's what it is. How much of information is captured by a specific thing? So a big eigenvalue means there's a lot of information, it's more important. Smaller ones means it's less useful, there's little spread. It tells you how each component explains the variation in data. It kind of measures the variance explained by each component. Okay. Any other questions? Okay, so I assume because everyone was getting it right, it was okay to move on. So please, if you don't quite get why everybody is saying it's a specific answer, you can stop me like just happened. Is there any other question on this, or do we progress? Okay, thank you. So let's look at CAT. Classification and regression tree. So it partitions data primarily based on feature cutoff values or covariance stationary conditions or nearest centroid distance. 10A. Okay. So CAT has to do with just think of it like having decision trees. At some point, you need to decide what, for example, I want to go out today. How much do you have? Where do you want to go? Is it just a December period? Will there be traffic? So it gives you those at every point in time. You have to decide, if I have 10K in my account, maybe I will stay home. If I have 50K, maybe I want to go out. If it's at night and I don't want to get caught, maybe police harassing me, maybe I'll stay home. If there's plenty of traffic because it's a holiday, maybe I'll stay home. You get, so those are the cutoff values that what makes you decide this is what to do or not to do. So the nearest centroid distance speaks to you having a cluster, like a group, different groups. And so you look at it to say, what do we do with this? So 10A. Okay, let's move on. Ensemble learning. Compared to a single model, ensemble learning most likely provides, number 11, lower stability and higher variance, more accurate and stable predictions. 11B. All right. So what's ensemble learning? It means you aggregate, everybody just comes together through everything. You know how they say there's no wrong, no suggestion is a stupid suggestion. Just bring everything in, and from there we'll see how we can make it work. That's basically what it is. So by the time you bring everything together, even that one person, there might be some people here, because I've seen some names who keep responding, and there's some people here who have had nothing to say. It's possible that some of those people are also getting the answers right, but they choose not to post it. So in ensemble learning, we say everybody throw it into the bucket, and then we'll see how we can have the best fit. That's basically what it is. So compared to a single model, imagine if it was only one person that was responding. I will not now know if everyone was on board, if I needed to spend time on this, or if you guys were getting it. So ensemble learning means everybody bring it together and then we find the best fit. That's B. So it's more accurate and it has stable predictions because we look at everything and we decide which is the best. Overfitting can still occur because if everybody brings everything in and someone is over zeros, you can start picking up different independent variables and adding it to the model, and you could still have issues. So that's why C is wrong, and A is wrong because it does improve stability over time. 12. A random forest classifier differs from a single decision tree because A, it combines predictions from multiple randomized trees. B, it uses only supervised, okay. learning. C, it eliminates bias errors entirely. A, okay. So I've already kind of spoken to it, bringing everything together. Why is B wrong? It uses supervised data, means you already know where you're coming from. C, nothing you do eliminates error entirely. There'll always be that margin of error. I expect that some of you do something sometimes where you even surprise yourself and you're wondering, okay, was this really me? You know, so whatever happens, no matter how good a fit a model is, even if you check all the boxes, there will always be that room for error. So PCA is most appropriate when an analyst wants to A, classify categorical outcomes, B, reduce dimensionality among highly correlated variables, and C, maximize classification margins. 13, B. Any other responses? Okay. So PCA looks at group of variables and says, these people are related. How do we break them out? Basically, how do we break it down into smaller components, smaller uncorrelated components? So A is wrong because it's not a classification thing. It doesn't determine whether it's right or wrong. And C is wrong because margins speak to SVM, support vector machine. Should I keep going? Can I get a thumbs up? All right, thank you. Thanks. Okay, so let's look at the eigenvalues again. Someone had asked about it. In PCA, the eigenvalues indicate the variance explained by each principal component, the Euclidean distance between clusters, and activation strength of hidden layer nodes. 14A, 14A. Oh. But I'm very happy based on what you explained. A, thank you. So there's some value add. Okay. Thank you. That makes me happy. So it measures the proportion of the variance explained by each component. B is we're discussing clusters. We're not speaking to that here. C is we're talking of hidden layers. That has to do with neural network. Thank you. Okay, so K-means clustering assigns observations to clusters primarily according to A, the nearest centroid distance, B, the recursive partitioning rules, C, the maximum margin separation. 15A. A. Okay. Exactly. Show me your friends and I'll tell you who you are. Awesome. So B is wrong because we're discussing partitioning rules as a cat. Okay. No, it's 215. I had to 215. And C, okay, is separation. That speaks to support vector machine. Okay. Hierarchical clustering. Agglomerative hierarchical clustering begins with one large cluster containing all observations, each observation treated at its own cluster, fixed centered as assignments. Number 16. B. B. Okay. B. Any explanation or we move on? So, is it that top down or down up? We remove C completely. That doesn't speak to what we're discussing. So agglomerative means you're doing me to my extended family. Some people, when they get married, they lock up and say, me, my wife, and my children, all of you shifts. Those are the agglo people. Then B are those who come from, it's all of us together. And what I had in mind was divide and rule. You know how your boss sees all of you banding together every Friday, all of you are hanging out as one drink come. How do I get someone to snitch on someone else in this office? And he starts a divide and rule. So that's the analogy I had in my head for the divisive one and then the aggro one. So let's keep going. So just think of it in terms of, are you a stingy person because you got married and you're loving all your family? Or are you the kind of boss that likes to do divide and rule, change your ways? Neural networks. It occurs through A, activation functions within hidden layers. A. Okay. So let's not spend time on this. Right. Deep learning. The deep neural networks are distinguished primarily by number 18. So please don't forget to add the number so I know which question you're responding to. 18, 8. Okay. Yeah. So we think of it like your brain firing on all cylinders. All right. Okay. Reinforcement learning differs from supervised learning because it requires labeled target outcomes. It learns through reward maximizing interactions or can't adapt to changing environments. Number 19. B. Okay. I'm liking this group. You guys were maybe being overly conservative. So reinforcement learning, exactly, is AI, how you train a dog, for example, or you just do that. What's the response? If you throw something out, what comes back? If it's something I want, then I take it in and I adapt. If it's not, then I disregard, that kind of thing. So examples are like self-driving cars. I don't know how cars drive better than human beings. And then games online, ChatGPT, yeah. Well, okay. Robotics, people that play chess online, those kind of things. So they learn and they know, don't do this. If he makes this move, you don't make that move. You do this instead. So it's reiterative and they keep learning and they keep improving, that kind of thing. Which is why those first robots, they couldn't walk and they used to sound funny, but now they're improving and they're looking more like humans. And they were expecting the Terminator to happen one of these days. Okay. So an analyst has thousands of correlated macroeconomic variables, but relatively few observations. The most appropriate initial technique is most likely okay. So it's well suited. PCA is well suited for high dimensional data sets. The know your neighbor is not good. We have to be in clicks for the know your neighbor or show me your friend. You have to be in clicks. You can't be too many. If not, you will dilute the effects we have. And then CAT is not for dimensionality reduction. Okay, so that's where we are on machine learning. I want to say you guys are doing very well. I think you guys are ready. You're almost ready for the exams as it were. Well done. Mm, okay. So let's go to regression. So all right. Are you guys ready to switch gears? Regression. Let's okay. Before we go into it, rate yourself 1 to 5. 1, I used level 1 to chop about 5. I'm ready to go. 5, 4, 2, 0.5. Was it years ago you wrote level 1? 2, okay. Okay, so we have a mixed breed. Some up there 4 5s, and I'm getting 1s and 2s. So, but then I don't trust you guys anymore because you guys always say I'm a 1 or 2, and you seem to be doing very well. So I don't trust you. So I'll add 1 to everybody's mark. I don't know if you remember that in school. The person that said 5, that means you're going to get a 6. When they're adding scores and you were on an E, you bump up, and then the person has an A is not going anywhere. See, I'll still be a 1.5. Don't worry. This is the easy part. This is the easy part. Okay, so let's look at there are different readings on multiple regression. I just picked one. So I didn't want to start with the basics because I assume we've all gone past that stage. So let's look at extensions of multiple regression. So a regression model that contains 50 observations, 4 variables, has a leverage of 0.35. Is it potentially influential? When you come in, will people stand up for you to say sit down or not? Number 1. 1C, 1B, 1 not sure. Okay, B. Okay, so let me explain and then let's see if the people, because I have A's and B's. So if we explain, then we'll see if you can all, if you explain, we'll see if you cannot get the answer. I think that would be a better way to go about it. So we know what outliers are, right? When everybody's going one way and someone decides to go a different direction, that's what outliers are. So if you're looking at mentally plot the X, Y axis in your head, right? An outlier will be an extreme Y, the extreme dependent variable. So if everybody's congregating in one place and you have one Y that is farther away, that's an outlier. Do the reverse for the X's. All the X's are together and you have one guy sitting somewhere. Everybody says, let's go and dance. And everybody goes up to dance. And one person, well, why did you come out? You're just sitting in one corner. You don't want to join us in dancing. So that's what leverage is. So it's an extreme observation and a dependent variable. And then it determines how much does this affect everyone else. If this one guy now is damping our spirits, do we just go ahead and party, or will he make all of us be sober? That's basically what leverage is. Make sense? No? Ah, okay. So I'm saying, Ari, thank you. So leverage is an outlier in quotes, right? That's basically what leverage is. But it's not for the independent variables, it's for the dependent variable, which is y. So if you're predicting, and you get a 2, you get a 5, you get a 7, you get a 3, and then you have a prediction that says 100. That is leverage. Do you get? Yes. Okay. Thank you. So there's a formula for calculating leverage. It's Baba talk about this for you so that you write it down and then do the calculation for me. It's you have a cutoff. So at what point do you decide this is within normal or it's extreme? That's what leverage, that there's a cutoff point. You don't just mentally look at it and say, yes, I think it's a good idea. You need to, there's a threshold point. So there's a formula. It's 3 into number of observations plus 1 over n. So would you do that calculation for me? That was why someone said they got 0.3. You calculated the cutoff point, but you did not use it to answer the question. Who was that? Yes. Hassan, you got 0.3. Yes. So you calculated the cutoff point, but you did not apply your answer to this. So if your leverage is higher than that value, then you say it's potentially influential. It means it's going to affect everybody else. If it's less, then it means it's different, but not significantly different. So Babatokwe, would you, Babatokwe and 2 calculated at 0.3. Hassan, so Hassan, finish your calculation. 0.3, and then what's the, finish it, A, B, or C? I want to wait for Hassan and Tokwe at this point. Hassan says B. Okay, so you finished it, thank you. So you have to remember, you know that if it was an exam, 0.3 will show up as one of the options if you're calculating. They do that a lot. They always look for, if you were supposed to remove tax and you don't, they'll put the answer there too. So that when you see it, you stop and say, I got it right. Meanwhile, -1. Okay, so but based on what I've said, and Ben has been kind enough to post the formula in the chat. I have 15 minutes, so I think we'll need to be fast. Would you want to calculate? If the leverage in this case, the observable is influential, thank you. Okay, so the observable range is 0.35. When you calculate the formula that Ben posted, you get 0.3. If it's higher than it, then it means it's possibly influential. The bigger it is, the more influence it will have, basically. Okay, so let's make progress since I have 15 minutes. So this was what I was speaking to. This is the formula that Ben posted. And when you do the calculation, you get 0.3, which was where Hassan stopped. And then you finish it, compare 0.35 to 0.3, it's higher. So it will be potentially influential. It means it will probably drag the line, the regression line to itself. It's big enough to drag. Yes, thank you, Ben. It's big enough to drag the regression line to itself. So what you're asking yourself is, it's just like a tug of war. When you have skinny people on one side and you have people who have been gymming for 5 years on one side, you expect it to be a no-brainer that the buff people pull the skinny people across the line. So it's something like that. The bigger the value compared to the cutoff, the more likelihood that it will pull the regression line to itself. So just have that analogy of a tug of war. And if you're skinny, I don't know why you're not going to the gym, as an aside. Okay. Outliers versus leverage. Which statement is most accurate? Every outlier is also high leverage. Every high leverage point is also an outlier. A high leverage point may not be an outlier. C? C, okay, yeah. So, like I said, it's specific to extreme X's. So, a high leverage point may not be an outlier. It might actually be very far away, but it might still be close in terms of the y-axis. So let's move on. Dummy variables. A dummy variable count. There are 5 industries. How many dummy variables should we include? A, 4. A, 4. Okay, yes. So what's the dummy variable? Is it that 1 or 0? Do I want to know whether I should include a specific effect in my variable, then I add a dummy variable. If it's 1, it means I include that. If it's 0, then I take it out, basically. So you'd always have n minus 1. There always has to be a base, as it were. So I have this regression line, explanation in 2. Ah, 1 acre. So what I was saying is that you're big does not mean you have influence. Some people are big for nothing. Do you understand that? Some people are big for nothing. Have you seen someone who is very big and then they punch him once and he runs away because he really doesn't have energy? Some people are big for nothing. So just have that in your head, that you are influential, that you're influential means you have what it takes. You have clout. Some people will wear agbada, but really no shishi for pockets. That's what this is speaking to. So just have that at the back of your head, that it's not by size. It's not by size. Can you also pull weight? If we say drop, can you drop? You get. So I need to, I didn't want to, I left regression for last, like I said, because, okay, thank you, you get it. I felt this would be a blowover. So we have 10 minutes left. So do you want to answer 4 quickly? If I have 2 correct answers, I move on. 4 is B. So look at it. 0 0.5, 1.1x, 0 0.4. This is dummy variable. When D is 1, this D is 1, then you have 0 0.4 times 1, which is 0 0.4, plus 0 plus 1.1. This is dx. You didn't see the x. Faithful, you probably didn't see the x. So it will be 1.1 x plus 0. Yeah, you didn't see the x. You see what I said? So guys, you keep showing that you actually know the material. Please read the questions. Please read the questions. I tell my people the difference between someone that makes a mistake and someone that does not know. No difference. You know it and you make a mistake and someone just randomly gets the wrong answer. Same difference. They won't give you points for when you know you need to make a mistake. So please read the questions. You would have gotten it if you had seen that there was an x. So it's 0.4x plus 1.1. So let's move on. Logistic regression is most appropriate when the dependable variable is number 5. Five A. 5A. It's B. It models binary outcomes, guys. It's linear regression. It models continuous outcomes. Please read that up. You can put it down, take a note and look at it again, guys. Okay. So, do you want to do leverage again? Or should we move on? Yes? Okay. So, let's do it. Okay. So, number 6, which observation is most likely a high leverage point? A, B, or C? You have to calculate it quickly. You have the formula now. 3 into K plus 1 over N. Temitope, please, can you take note of what it was? I don't have the time to go back. I'm sorry. What question did you have an issue with? So that while people are calculating this, I can answer you. Which question did you want me to go back to? But guys, we're calculating number 6. I've not seen any answer yet. Temitope, what question did you have an issue with? I can explain why people are calculating. 6A. Good. 7. Which statement is most accurate? Thank you. Let's go to 7. Which statement is most accurate? A may influence coefficients despite small residuals. B cannot influence results because leverage is low. C, high leverage and outliers are identical. Let me check 5 for you here. Number 7. You wrote number 1, faithful. Number 5, let me see if I can find it. A, okay. So we have 2 A's. Thank you. For technology firms, the intercept is equal to, so D is 1 for technology firms. What's the intercept equal to? I have 6 minutes. Number 5. Let me see if I can find number 5 for you. 6 and 7 are A, I think. No, both wrong. Ben, is that A for 8 or for 8B, 8C? What of 9? You guys try number 9, please. I have 5 minutes left. Okay, so number 5 question you asked was the logistic regression. That one is very easy. If you just check the curriculum, you'll see that it is basically for binary categorical outcomes. It doesn't, it's for continuous, you use linear. Number 9, you guys are not responding. So that one, the curriculum will kill that for you, easy. That one's not a difficult thing. Or if you don't have time, just remember that you guys are not responding anymore. Number 9, 9B, okay? All right. So 8, we had 2 different answers for 8. We had B and we had C. So let's look at number 8. 9, let me see. 9A, 9B. Okay, so let's look at number 8. For technology firms, the intercept is equal to, this is a dummy variable, and it is 1 when you have technology firms. So this will be 2.1 plus 2.5. What did you people see? You saw the D or you saw an X. Why was this wrong? I'm struggling. Why are you struggling? So a dummy variable is 1 when, okay, in this case, now look at this question, right? 1 acre. A dummy variable either makes something be relevant or not. So if it rains, do this. If it doesn't rain, don't do it. You get, if the person dashes me money, I'll do this. If the person doesn't dash money, I'll do this. So it always has a value of 0 or 1. So in this equation, the equation is 0.7x plus 1.2d. D is 1 when it's a technology firm. It means if it's not a technology firm, this will be 0. And this whole portion will drop off. This whole portion drops off if this is not a technology firm. But if it's a technology firm, then this becomes 1. And so your equation is plus 1.2. If it's not a technology firm, this becomes 0. And this 1.2d drops off. So your equation is 2.5 point 0.7, right? Yes, you get it now. So what's the intercept for a technology firm? It means this is 1. So this is 1.2 plus 2.5. Do you get it now? Okay, thank you. So let me see if there's any other question we can take before. Logistic, if we are not reading logistic, I have 3 minutes left. Do we try this as the last question before we simmer down? So the coefficient is best interpreted as, I've asked you this thing before. Number 10. B. Thank you. 11. Thank you, guys. 11. Why is logistic transformation used? A. Thank you. Okay. So I will pause at this point. I only have 2 minutes left. I hope I have been helpful, and I hope more importantly that I've given you more confidence in how far you've read, and that I've also highlighted areas that you need to do further study on. Please, you will want to consolidate what you know and consolidate what you know, keep studying. I will not ask you to read a lot now. I'll ask you to solve as much as you can. You want to be sure you know what you know. That's my advice to you. I have one slide that I must show before I go. Just one slide that I will show before I go. And this is it. I want to say congratulations to all of you. I'm clapping in advance. Let me be the first to say congratulations for the hard work. Thank you, everybody. Well done, guys. Good job. Congrats, guys. No tension. Down tension. You got this. I mean, see, your answers were correct almost all the time. So well done. And congratulations in advance. Looking forward to L3 and getting your life back. No, no fear. You got this. Ben, you were giving us formulas. You got this. You're fine. All right. Thank you very much, guys. Be over to you. Okay. So it looks like you guys are in luck. If you're not tired of hearing my sweet voice yet, we can still do one or two more. Is that fine? This my thank you. You say it twice, so because when I say I'm done again, you tell me thank you. Should I keep going, guys? All right, thank you. But has it been helpful so far? Chamaka, don't laugh. I want my thank you twice. When I say I'm done, you clap for me again and say thank you. Okay. Is the years that I should keep going or the years that it has been helpful? Let's go. All right. I like your energy. You see? You see why I'm saying that you guys are on point. Focusing on mock, absolutely, absolutely, absolutely. I'm saying if there's one thing you do, you must have answered all the questions that CFA themselves set at least twice. Kaplan will not do it. There's always a slight variation in Kaplan questions versus, like I said, they teach you more than you know. CFA is actually very simple when you enter the hall. So where were we? I don't even know when. See, it was where were we? Was it somewhere here? I was rushing at some point. Let me see. So please, Kaplan is not bad, but when you're getting close to exam time, you should be crunching all every CFA question you see solve. Examples, end of chapter questions, definitely the mock. I think if you do that 2, 3, as many times as you can, you'll be ready for the exam. You generally don't need any big deal. No, nothing too serious, honestly. CFA, when you get in, you realize that you were prepared most times, and that's always a problem. So if you guys have been crunching all sorts of question sets, please, this last stretch, focus on CFA alone. They're the ones that know how to set the questions. And so that to give you a feel of what to expect. Their questions are always very different and it's always very easy. Just do soft questions, CFA questions, please. These people get you up till this point. Let's see if they finish it for you. Just like how a bride is getting married and her dad walks out to the point and husband takes over. So please, let this be you and CFA's marriage. Ditch all the other people that got you here. All those girls I used to use and dumb people. Okay. Where were we? Was this where yeah, I think we answered. Let me see the last answer. 11. Okay. Yeah, so we're past this. 11. Okay. So let's go to 12. Number 12. You guys are stuck with me for this longer. B. Okay. B is correct. Okay. That was actually the last question in this section. Okay, so let me keep going. We've done that. Let me see which other regression we can do. I have it. Let's see. Okay. So let's look at evaluating regression model fit. Number one, where is the fastest finger set people? Which model is best if the analyst prioritizes overall fit with penalty for overfitting? 1C. Who else wants to try number one? C. C. B. Okay. Okay, so try number two. B. Okay, so the number one, we have B, two, some B's and some C's. Okay, let's look at number two. Why does the adjusted R squared fall from model B to C? To C. To C. A. A. Okay, so let's look at it. I'll be toggling back and forth for this one. There's a B. This two is all over the place. Okay, so let's see. We'll toggle back and forth. So B. One is B. Which model? I need a highlighter for this. Which model is best fit if you prioritize overall fit with penalty for overfitting? Once you hear that, you should know we're looking to these bad boys here, AIC and BIC. If you're going to penalize for overfitting, we're talking of AIC and BIC, clearly. So the rule is you want to, the smarter the better, basically, right? So if you want to prioritize overall fit, these two help you fit your model as best as possible. So I'm not sure why there was a divergence in responses on this one. So if you look at the, forgot the lower, yes, lower is better. Lower is better. So do you see why B is the correct answer now? Or should I ask you guys to answer it again? Okay, so now you know. So do you want to try number two, even though I had already flashed the answer before? Lower is better, please. Lower is better. Because if you look at the formula for AIC and BIC, the positive number, the long portion is the one that, which one are we looking at? For this model, AIC is 120. If you look at these three, the lowest here is this. The lowest here is this, but then if you look at the R squared too, it's slightly higher. Yes, it's overall fit, exactly. Waneka, you see your voice is getting strong now. Yes, thank you. So why does the adjusted R squared fall from model B to model C? Because this one adds little explanatory power when you adjust it. Okay, so let's see how far we can go. So I have explained AIC and BIC. Let's look at number three. Number 3. Any takers for number 3? You can't see it. Oh, you can see it now. Okay. Which is preferred under BIC? Exactly. Thank you. We just talked about it. Lower the better. Okay. So number 4, what's the correct conclusion? Aha. Who are those people that don't like hypothesis testing? You must love it. You must love it. Okay, so take your time. What's the correct conclusion? So the hypothesis test is B2, B3 is equal to 0, which is usually what the hypothesis test is, except you want to say it's not equal to something, or it's higher or lower, but its default is that it will be equal to 0. So what you're saying is that it's not statistically significant, is what the null hypothesis is. And then the alternate hypothesis would always be that it is. So if you fail to reject B0, then it means you're admitting that it's statistically significant. Did I just speak jargon? Should I take that again? Because you would have to attempt. Nobody's even making an attempt. Yes. Okay. So you have this model 0.4, 1.3 market, 0.5 value factor, 0.2 fear factor, and they're saying the market and the value factor, is it equal to 0? If it's equal to 0, it means it's not adding any value. I can actually just take them out and let the regression line be 0.4 plus 0.2 fear factor. This is, sorry, I should be using this. Here, this is what I was speaking to. So this is B1, B2, and B3. Okay, B2 and B3. So this is the value factor, high minus low. This is volatility index. How afraid are people? Are they calm and happy and trusting the system, or are they worried? Are they jittery? That's what these two speak to. So hypothesis test is, this is B1, this is B2, this is B3, this is B0, the coefficients. So the hypothesis test is this and this, are they equal to 0? Means, are they statistically significant? Should I take them out of this equation and just let the equation be return on investments is equal to 0.4 plus the market times 1.3 plus an error term? F statistics is 6.2. Critical factor is 3. So, okay, people are responding. I'm sorry, I wasn't checking. 5A, 4B. Oh, okay. Nice. Okay. All right. So, some people were already ahead of me. I was explaining. So, there's usually the rule. So if the F statistic, this one, exceeds the critical value, so this is the one you calculate, the F statistic. If it is greater than the critical value, F statistics, you would have to use the ANOVA table, the analysis of variance table. That's what this is a question that is very easy to get because they will give you everything you need. Unlike that time when we were saying 3 into something plus something over something. In this case, they probably would furnish you with all the data, and all they ask you to do is choose. So this is, if you've not had time to study ANOVA, please just go and look at that table where you have mean square error, F statistic. It's one of the easiest questions to get, and it doesn't take time. You don't calculate anything, you just pick the values and move on. So in this case, the F statistic has been given and it's 6.2. The critical value is 3. So you're comparing both. If it is higher than the critical value, you're rejecting H0. It means either this or this is significant. Oh, okay. So they said the next person is in. So please, the last word to you guys, please, is just if you haven't done this, just take a quick look at it. It's very easy to understand and it's not take your time at all. You don't have to calculate anything, and it's very cheap marks to pick up. Don't leave it on the table. I beg, I will show that my thank you. You put more back for me again. I'm just kidding. Well, thank you very much, guys. It's been fun. Yes, so thank you. And congratulations in advance. Very important. I wish you all success, guys. Irrespective of where they draw the line, you'll always cross and you'll get that congratulations email. That's what I did for you. Thank you.
Okay. Good afternoon, everyone. Please confirm you can hear me. Okay. Please give me a few minutes, a few sessions. Let me put on my screen. Stop my screen. I'm trying to change locations because where I am is a bit noisy. So just give me like 2 minutes. Okay, share my screen now. Stop. Okay, please confirm if you can see my screen. Okay. All right. So that means you can see my screen. Thank you. Good afternoon, everyone. My name is Chukwuka, those you know, and I will be taking us briefly through the review session for derivatives level 2. So I understand that this is for the May diet or the May exam, and by now I'm sure everyone is ready to walk into that hall and show the institute what they've got. So by all means, this is just a way to share final words or final tips that might be helpful. So I wrote level 2 in 2023 and around November. And it was a good experience for me. And for you to be in level 2, that means you've already passed level 1. You understand how the derivatives exam can be. So, but before we even enter into all of that, I will need us to actually unmute our mics, or you can type in the chat box answers to some of the questions I will be asking. Don't worry, it's based on the curriculum. So if you've covered the curriculum, which I hope you have, then there should be no problems for you. So before we even get into the questions, almost every derivatives question, from my experience in level 2, it maps to one of 4 things, and I will show us what these things are, and I'll give you I'll give you an example of how to think around this and tell you exactly where the exam might be a bit tricky. especially for level two, it's not like level one where there are single questions. This is based on Vinet, so you need to actually know how to follow the facts in each case to do very well. So this is the pop quiz. First question is, oh, before the pop quiz. So derivatives is about 7.5% of the curriculum. The weightage for the exam derivatives is 5 to 10%, alternatives 5 to 10%, portfolio management is about 10 to 15%, and so on and so forth. It might look like it's one of the lower categories for the curriculum in the curriculum, but every percentage counts. So because of its relatively smaller weight compared to other topics in a level two curriculum, you may not see so many derivatives questions in your exam. But I want us to be so prepared such that even if you see just two questions, you are getting those two questions correctly. So let's head into the quiz. So the first reading one, first is pricing and valuation of forward commitments. So I'll give us 2 minutes to read the question, and then if you want to use your mic to answer it, that's fine. Or if you want to type it to the chat box, that's also fine. So 2 minutes to read and provide answer before I share the answer. Let me start my 2 minute countdown. So if you have your answer, you can just type it on the chat box, or you can just unmute your mic and speak. Okay, 2 minutes are up. Let me look at the chat box. Okay, someone says B A A A. Hmm. Okay, I mean that's great attempts. So let me show what the answer is. The answer is actually C. So they're asking that. So which of the statements regarding euro-dollar futures contract price is correct? First one is saying that if the contract futures price is less than the price suggested by the carry arbitrage forward, then the futures contract should be purchased. So according to the curriculum, this is correct, because the only time when there's an arbitrary opportunity in the derivatives market is if the price is either less than or higher than the no arbitrage price. So in this case, if the futures price is less than the price suggested by the carry arbitrage model, which is a no arbitrage price, then you should buy the futures contract. So always remember that no arbitrage condition states that there should be no opportunity to make an arbitrage profit, which is a risk-free profit, by ensuring that the price of the contract matches the price of the modeled price. But if there's any single deviation at all, then you can either buy the contract or you can short the contract. So if statement one is correct, statement two, based on the cost of carry model, the futures price will be higher if the underlying euro-dollar bonds upcoming interest payments was expected in 5 months instead of two. So the answer is that is also correct, because you know that there's time value of money. So the higher, the longer the tenure of the contract, then the expected interest price will be lower, because the extended time means that the present value will be much smaller than what it would be if it was in 2 months. So 5 months, you have a lower discount rate. 2 months, you have a higher discount rate. So remember that discount rate and price, there's a an inverse relationship. So if the discount rate for 5 months is, if discount rate based on 5 months is going to be lower than the discount rate based on 2 months, then it means that the price of a 5 month contract will be higher. So just a way to, this is just an example of the kind of question that you can expect. And I also want to mention that if you've gone through the curriculum, if you like you use prep classes or you do self-study or you watched videos, as long as you've based your study on the curriculum, then you have all the tips, all the tools you need to actually do very well. So both statements are correct. So if you, so, okay, I say Angenica chose C, yeah, that's fine. So this is what, just need to keep this in mind as you do your final reviews. So the next question is also on the same reading. So I'll give us 1 minute to just read this question. I think after this question, we'll just dive into the review session as a whole, save some time. So just 1 minute to read this and then provide answers. So it's about pricing swaps. Okay, so time is up. So let me see what our answers are. C. Wow, everybody. Okay, that's good. Okay, yeah. So everyone got this correctly. Everyone that typed in the group on the chat box got this correctly. So this is a very simple. I remember when I was writing my own exam. So I had like, I can't remember how many questions came, but it was less than 5. But the interesting thing is that those questions, if you know exactly what you're doing, like what the last facilitator was saying, some nuances, small, easy questions that will come, that once you know your formula, you just plug it in and you get the right answer. So in this case, this swap pricing equation is 1 minus present value, whereby the sum total of all the present values. So you get the sum of the present value factors, then you use this, plug in the figures into this formula, and you get the right answer. So these kind of questions are the ones that have a very good likelihood of coming or being tested. All the other ones where there's a long formula, there's complex stuff, ND1, ND2, nobody's going to test you on those. But if it's questions like this, small pricing questions, small valuation questions, those are the things that will earn you that 75 percentile kind of score in derivatives. So I'll just skip through this one because there's no more time to answer our question. So just things to note. So there are 4 main pillars, in derivatives for level 2. All the questions that we see, all the problems is based on 4 things: valuation, either at the start or during the life of the contract; payoff of a contract of a derivative versus the profits made; hedging mechanics; and then put call parity. So every question you see is going to be based on any of these 4 pillars or any of these 4 concepts. So let me start with the first one, valuation. Questions will come to ask you, what's the value of these contracts at the beginning of the contract, or at year 3, or at year 2? So at initiation, a derivative is priced so that its value is 0. At the beginning, neither party pays the other. The contract is struck at a fair forward price, that's F0 or FO. But during the life of the contract, market conditions change, and then the asset's spot price moves. Why? Interest rates move. The original forward price will stay fixed, but the value of the contract we will always change from zero. Let me see if I can write. Hold on. Where's the board? Ah, okay. Okay, whiteboard, yes. Yes. So let me try to write on the board. Okay. So let's do an example. So for example, remember we said that at the initiation, the price of the forward price is zero, but as time goes on, the value changes. So let's do an example. So you enter a 6 month forward at F. um, what's happening? I'm unable to write on this board. Um, wow. Okay. Okay, if I'm able to use it, but I'll just narrate the question. So during the life of a contract, let's say, for example, you enter a 6 month contract, a forward at FO 102. Then 3 months later, the equivalent forward price for the remaining maturity is now 105. With assuming the risk-free rate is 4%, then the value of the contract is going to be the current price, which is 105, minus the initial forward price of 102, multiplied by the interest rate times number of months. Okay, let me see whether I can just share my screen. I don't know why this is not letting me. Yes, I'm having issues with my screen. Can you see my screen now? Hello? Can anyone see my screen? Okay, thank you. So let me use this PowerPoint to make the example. What's happening? I can't work. Sorry, I'm having some technical issues with my slides. Hey, hey, my computer is hanging. This is not normal. Okay. So let me just narrate the example. Okay. If I can't do a live example here, I'll just continue narrating it. So the second thing I was going to discuss after the fact that the first thing that the question is asking about, or the first thing derivative is about, is valuation, either at initiation or during the life of the contract. So at initiation, the key, the key gist is that the derivative is priced so that its value is zero at the beginning, but during the life of the contract, because market conditions change, then the spot price of the assets will move. This is going to change the value of the forward contracts. And that value is valued to either the writer of the contract or the buyer of the contract. Now, please watch out. Sometimes it is possible to confuse price with value. Always remember that the forward price is fixed at initiation, but the value changes daily. So they are not the same. Price is different from value. And you might see an exam question where they're asking, okay, what is the price? What's the difference between the price and the value? Or they ask you what will be the value as at this particular date. And they'll put in one of the options, they'll put the initial price and then they'll put a value which you should calculate. The the important thing to note is that the price will not be it's not going to be the same as the value as long as we have moved away from the initiation, as long as time has moved. At the beginning of the contract, at contract initiation, price and value are the same. They are the same. But once time passes and exchange rates move or the spot price moves, then value is never going to be the same as the price. So please just take note of this. So if a question asks you what is the value of the forward to the long, or what is the value of the forward to the writer, what you are solving for is value, not the price. So if it asks you for forward price, that is F, not V. So always one thing you should note, which of course I believe that you'd have also gotten, how to go around this, is when you're reading questions, please read it, if possible, read it slightly out loud so that you know exactly what they're asking for. Sometimes they'll put a question, a particular word in italics. They'll say which of this is not, or which of this, what is the value of the contract at initiation. So you need to be very, very careful when you read, because derivatives is not something that you can just, you have to know exactly what you are doing. And what you are doing is going to be determined by the question they're asking you. So number one, remember that value and price are different once we have moved beyond initiation, once time has passed, once prices have moved, once the interest is no longer the same. Into if you are solving for the price, if you're solving for the value, it is going to be a different figure from what you had at contract initiation. Then, so the next pillar that I'll be discussing, I'm so sorry, I'm unable to write on the whiteboard. I don't know why it's not allowing me to do that. But next pillar that I'll be discussing is payoff versus profit. So this particular one, it's especially when you're calculating the value of a, let's say, of a call option, for example. Let's say you have, if it's a 6 month, 6 month option, and then you are looking to exit by the third month, you need to exactly know how much cash will I get when I sell, and what is the profit from this, what's the profit from this activity or this action. So that this is where you see where you have to calculate maximum profit, minimum profit, or break-even profit, and so on and so forth. So payoff is what you receive at the expiry date or at the time of sale, but profit is what you actually make. So for a call, the payoff is a maximum of zero and the spot price minus the strike price. But for profits, the payoff profit is actually the payoff minus the future price, minus the future value of the premium you paid. Most of the times when you please get this, most of the time when you see a question like this in the exam, they will always ask you for profit, not payoff, because payoff is easy to calculate. It's just maximum of zero. If it's a call, maximum of zero, and the spot price minus the exercise price. For a put, it is maximum of the exercise price minus the spot price and zero. So the exam will most likely ask you for profits, not payoff. So, for example, if you buy a put with a strike of 50 for, I really wish I can write this out. So I don't know why. Just let me just try one more time. Presenter mode. Okay, let me see. Thank you for that. Let me try. Hmm. Let me try presenter mode. Hmm. So let me try this. Let me try the annotation tool. So for example, if you buy a put, hmm, so The strike of the put is $50. $50. And the premium you pay is 2.5. No, let me just, this is too slow. Let me use the chat box. Okay. Price, strike price of puts. Strike price is $50. The premium is $2.50. And then the risk-free rate is 5%. So if you're asked, okay, what is the payoff? Although remember that I said that most of the time what they'll be asking you for is not payoff, to be asking for profits, but just so you can calculate payoff. So at expiry, oh no, I'm typing on the chat box, please. You can look at the chat box. So I'm not able to annotate on the board, but you can just look at the chat box. So I'll put up what I'm saying there. I'll be typing it there. So at expiry, price of the assets is $44. So if you're asked, what is the payoff? Please, can you type the payoff based on this question I've seen? Okay. So the payoff will be maximum of 0 and, oh yes, exactly. So the payoff is 6. So thanks. So I can see your feedback. Thanks. Payoff is 6. So if you're asked, what is the profit? So what is the profit? Okay, I'm seeing answers. 3.5. Okay, yeah, good attempt. Remember, derivatives and time value of money are 5 and 6. Yes, yeah, this is correct. This is correct. Binta is correct. 3.33. So actually, you need to calculate the value, the present value of that $250. That's $250.07, $2.50 by saying that's 2.50. So the future value of that premium is 2.5 times 1.05, which is 2.625. 625. So that means the payoff, or the profit rather, profit is $6 minus 2.625, which is 3.375. So when you're calculating, when they ask you for profits, remember to apply the time value of money to the value you get. So you don't just say 6 minus 2.62. You don't say 6 because the payoff is 0.5 minus, it's 50 minus 44, that's 6. Then you just take it like that. You need to also factor in time value of money. So please don't forget to future value the premium when you're calculating. The exam, in the question, you see some of the answers you provided as an option, but the right answer will always be there. You need to take account of time value of money in that calculation. So the next pillar that I'll be talking about is hedging mechanics. So every hedging question is asking you the same thing. What direction do you think the market is going to, based on your point of view, and how many contracts do you need to buy? Every hedging question is asking you, what should you be buying or should you be shorting? One. Number two, how many contracts should you buy? So So if you have a long position, for example, what you care about is the market going down. So how to hedge that position is to take the opposite side, take the opposite position. So for an equity portfolio, the number of futures contracts you need to get to hedge your position is the target beta minus the portfolio beta divided by beta of the futures. Then of course multiplied by ratio of portfolio value to future value. So let me just note that down. So target beta minus the portfolio beta divided by the beta of futures, multiplied by the ratio of portfolio value to futures value. For fixed income, it's the same structure. When you are asked to hedge a portfolio, the first thing to do is to calculate for the number of contracts that moves you from your current duration to your target duration. So the most common hedging trap that the examiner can set is that a fixed rate payer is effectively short bonds. So when you are paying fixed rates, if interest rates rise and bond prices fall, you will, as a fixed rate payer, you're actually benefiting from rising rates because you can always, instead of it paying a higher amount due to if compared to if the rate is floating, you are still paying your fixed amount. So you stand to benefit from the higher interest rates because what you are doing is you are paying the fixed rate. So when interest rate is higher, it benefits the fixed rate payer. But when interest rate is actually going down, if you are a fixed rate payer, you are worse off because you could have actually been paying a lower interest rate. So these are things you should just note as we prepare to know, first of all, which direction am I going. If you are short, if you are short an asset, or you're short the underlying, and you are asked to hedge, that means automatically you're going to have to buy the particular contract you need to buy. And for equities, to know the number of contracts you need to buy is target beta minus the portfolio beta divided by beta of futures times the multiplier, the ratio of the portfolio value to futures value. For fixed income, the same thing, your current duration minus your target duration minus the current duration. So those formulas are in the curriculum. So you just need to think through it. What's my position? If I want to hedge, I need to take the opposite position. So a key thing to note as you prepare for the exam or as you are wrapping up with preparation is that the sign you use when calculating matters. A long equity portfolio is hedged by shorting futures. On the contrary, a short equity portfolio is hedged by longing futures. So that's a foundation for hedging. Once you have that in mind, you know the exact position you're taking, then calculating the number of contracts is pretty straightforward once you use the formula. Then also for a tip for the exam, so the first thing to do is to draw the position. So it actually helps. That's why they give you a piece of paper at the exam hall. You can use that paper to your advantage. So you write down, am I long or short in the line? Then my hedge is opposite. So for a practice question, so let me just quickly share the practice question. What's happening to my PowerPoint is just misbehaving. I'm unable to change my slides. Okay, no, let me just move the questions to the chat box. Question. So please look at the chat box for a question. Okay, said you were going to type a formula around target. Okay, yes, I will send that formula after this question. Please, can we attempt this question? A portfolio manager holds $10 million in equity. Beta is currently 1.2, but the S&P futures price is $250,000 per contract, and the futures beta is 1. So always, the futures beta is always going to be 1 because that's like you buying the entire market in quotes. So in this case, need to calculate how many contracts does this portfolio manager need to buy and in which direction. So please just attempt this question on the group, on the chat box. Okay. Okay. Can I get answers if you have answers to this question? So the formula is beta, the target beta minus the portfolio beta divided by the beta of the futures times the multiplier between times the portfolio value divided by the contract multiplier or the price of the contract. Maybe let me just type that question, that formula down. So that formula I've posted now is formula for the number of contracts that you need to buy. Okay. Yes, I can see Adetayo's question answer 28. So your 28 does not have a sign. Is it plus 28 or minus 28? Because that actually matters. You need to know exactly are we buying or are we shorting? Yes, 20 minus 28 short. So that's correct. So remember the mini roadmap that I shared. The first thing to do, what's my position? Then to hedge, I need to go opposite that position and then apply the formula to know how many contracts I'm buying. So in this case, the portfolio manager holds 10 million. That means she's long 10 million in equities. So she wants to hedge by reducing the beta to 0.5. That means she has to sell or she has to go short S&P 500 futures. And then once we decide that she has to go short, then we can now calculate how many contracts. So let me quickly paste up the formula on the chat, the calculation in chat box. So number of futures contracts. So that's the target beta, which is 0.5, minus the current portfolio beta, which is 1.2, divided by the beta of the futures times the value of portfolio is $10 million, and the price of each futures is 250,000. When you do that arithmetic, you get minus 28 contracts. That means she should short the contracts. And I'm sure from a practice questions, you'd have seen that in a question like this, you will see 28, you see minus 28, and you see another figure. So the first thing to do before you even start calculating is to determine which direction am I facing. Because you are long, the portfolio manager is long 10 million in equities, then to hedge or to reduce the beta, she has to short. So automatically that excludes 28 from the question. It can't be 28. In fact, so sometimes you don't even have to calculate. Once you just understand this logic, you can just, especially if the third option is also a positive number, just pick your minus sign because that is the one that is correct. So to know the number of futures contracts you get is the target beta minus the portfolio beta divided by 1 times the portfolio value divided by the value of the contract. So that's on hedging mechanics. And the final pillar that I'll be discussing today is put call parity. So put call parity connects the price of a call, of a put, the stock, and a risk-free bond. Let me see if I can get this thing to work. Okay, please can you see my screen? No, this is the best I can do for now. So postcode parity is saying that is trying to what is the price of the assets, the price of the assets, price of a call, the price of a risk-free bond. So it's usually stock. So it connects the price of a call, the put, the stock, and a risk-free bond. So at the left is the price of a call option and a risk-free bond, and at the right is the price of a put option and the value of the underlying. So this is, if you're familiar with this, I'm sure you're familiar with this. This is called a protective put, and this is called a fiduciary call. So the fourth pillar of derivatives, especially in level two, is around post call parity, and the relationship. And in fact, you don't even have, you don't really need to cram it. Also, just understand that financing financing a call using a risk-free bond and protecting your puts, protecting your stock option, you're long the stock, so you buy a put to protect this position. So understanding why the put call parity is important is because holding a call and investing the present value of X, that is a strike at a risk-free rate, gives you the same payoff as holding a put and the stock. If the by definition, if the left side and the right side, that is, if the fiduciary call and the protective put, if they're not the same, then it gives rise to arbitrage. So on the black BSM Greeks, on the BSM Greeks, the exam will not ask you to calculate the theta, they want you to calculate Vega, they want you to calculate any of those Greeks. But it will ask you, what it will most likely ask is that if volatility increases, what happens to the option value? So one thing you need to really understand is the direction of each Greek for calls and puts. So let me just give you a quick summary. So delta focuses on how much will the option move per $1 in the value of the underlying. So delta is looking at what is the relationship between the price of the option and the price of the underlying. Vega is always positive for long option, and more volatility means more value. So the exam will not ask you to define the delta. The exam will ask you to define Vega. It won't ask you to define any of the Greeks. It just wants to know what is the implication of each of the Greeks in for calls and for puts. So allow me to paste this on the chat box. So summary of the Greeks. Delta is looking at how much does the option move per one move in the underlying. Vega is always positive for long options, and more volatility means more value. Number three, theta is almost always positive for long options, and time decay hurts. So theta is the relationship between the price of the option and time. So the longer the time of a long call option, the more there's wiggle room for the price to fluctuate. So theta is almost always negative for long options, and time decay is not your friend when you are long the option. And then finally, rho is the relationship in the price of between the price of the option and the risk-free rates. So rho is positive for calls and is negative for puts. So when it comes to these option Greeks, just these are the things you keep in mind. And even if you look at the summary of this particular reading, this is reading 3. If you look at the summary of the section, they summarize it there for you that these are things you actually need to focus on. Delta, Vega, theta, and rho. The implication is that if you have a long option, then Vega will have a positive implication for you. I know in some questions they will ask you that which between these two options, which one, and then let's say option one has a higher gamma than the other one, and then the option one also has a lower vega than the other one. They will put information that you really do not need in questions, but all you need to focus on is these principles. That's delta, vega, theta, rho. These rules, these are the things you just need to focus on. And then lastly, one thing we should also note, and I also had the same experience while writing my own exam, is that vega is not zero. It's almost never zero. Vega is not zero for either calls or puts. Both calls and puts gain value when volatility rises. It just depends on which side you are on. Vega is always positive for any long option position. And then also one last tip to mention on put call parity. When you are calculating, when if you want to solve a question on put call parity, always try to rearrange the formula on paper before you solve. I mean, it really helped me. You write, first of all, always make sure that your fiduciary call is on the left and then your protective puts on the right. Because they'll ask you a question. Let me see, please just let me see if I can find a question like that in the curriculum. Where they'll ask you that what's the price of a protective hold on. Let's just see. Yes, I saw it a while ago. Yeah, where's it? So it's actually a very simple question, but because some people might not realize that it's actually just post parity they're asking you, you might start thinking that, oh, how do I solve this one? But this is I can't find a question anymore. But anyway, if they ask you to calculate the value of the put option, and then they give you see the other inputs, the price of the call, the underlying, and then the strike or the risk-free bond. First of all, rearrange the formula to have just the way it's on the screen, to have the fiduciary call on the left and the protective put on the right. So you can now substitute the figures to calculate what you need to calculate. So a question, so I'll type the question on the chat box. So quick question. So, you for some check maturity. So, if the SO is this, we'll find this. Okay, so let's attempt this question. Okay, I can see Chinwe's question on gamma. Yes, I'll respond to that. Let's just quickly take this question. So using a protocol parity, same strike, same maturity, just calculate, is there an arbitrage in this scenario? Okay, if yes, please describe the trade. Yes, I agree with you. There is a trade, there's an arbitrage opportunity. So you need to, yeah. So what is the trade? How will you take advantage of this scenario? I wish this to let me. So this can you see my screen? This is the answer. So because, oops, okay, let me see. Yes. Mm-hmm. Yes, short C. Okay. So because the protective put is the value is 54.01 and for the fiduciary call is just 51, that means the call is overpriced. Okay, now okay. So because the call is overpriced, what you should do is to sell the call, to buy the put, buy the stock, and borrow at the borrow PVX essentially. So a kind of question like that, all you have to do is just to plug in the figures into that put call parity formula we calculated that I displayed earlier, and then you'll be able to calculate and get the right answer. And then someone asked about gamma. So yes, gamma is what makes delta unstable. All right. Gamma looks at the relationship between the price of the underlying and the delta of that same derivative. For example, you can set up a perfect delta hedge this morning, and then the stock price moves, let's say $5. Your delta has now changed, and what tracks that change in your delta because of the change in price of the underlying is gamma. So gamma is especially useful when you are trying to delta hedge a position. So a high gamma means that your delta is very sensitive to price move, and it's good if you are long. Okay, I think this is breakdown. This is the impact, the insight. If you are long a position, then a high gamma is beneficial for you. It means that your delta is very sensitive to price moves. But if you are short a high gamma of is of a if a derivative has a high gamma, then it's not going to be favorable for you. Remember that we said delta is positive for long positions. So automatically that means that gamma is also positive for long positions. So if you see a question, I don't know how to test that, but if you see a question that's they're asking what is the impact on gamma on this long position, it means that there is a benefit if you are long the option, but it is a bit harmful, or it will be more costly if a derivative has a long position as a high gamma if you are short. So those are those things that you need to just consider that. So finally, I think I have just a few minutes left. I'll just go through some specific issues that you might face, or some traps. I like call them traps now, or let me say just things to keep in mind, especially as you prepare for the exam, the last series of preparations that you are going through. The first one is that for swaps, you do not confuse the notional exchange with the actual payments. Yes, do not confuse notional exchange with actual payments. In interest rate swaps, the notional is never exchanged. It's only the net settlement that changes hand. If the fixed rate of a swap is higher than a floating rate, then the fixed rate payer pays the net difference. That's all you need to know about swaps. If you might say a question, they'll ask that, okay, how much will be exchanged at the initiation of this particular contract? They are just trying to test your knowledge. You don't exchange notional on a swap at any point in time. It's only the net settlements or the cash flows actually move at the end of the period. Number two, on forwards, do not apply the cost of carry incorrectly. So what you should focus on is that formula, if you remember that formula, you need to add storage cost. Although this is more like level one, so it's just worth keeping in mind. You want to add storage costs to the forward price, but deduct dividends and convenience yield from the price of the forward. The exam might test this, and I don't know, but storage cost is adding to the price, but dividends and convenience yield, you need to deduct it. Again, as I said before, this particular section is not, I'm not really sure how testable it is, but it's just good to note that's in the example. You add costs, deduct benefits. Then the next thing is that for options, again, which we mentioned earlier, do not confuse exercise value with time value. Yeah, I remember this particular question when I was also like preparing for my exam. The option value is equal to the intrinsic value plus time value. Deep in the money options have near zero, almost zero time value because there's just a few optionality left. Before an option expires, the time value is always non-negative, but at the expiration date, time value becomes zero. Then the value of the option now depends strictly on the intrinsic value. Please remember, the value of an option is the sum of the intrinsic value and the time value. And from any period before maturity or before expiration, the call option or the put option will have a positive time value. But once we get to expiration date, then then the option has a low or zero time value. Number four is that for American call options, do not assume that there'll be early exercise. American calls on non-dividend paying stocks, it's fine to say, okay, you don't exercise early, but on dividend paying stocks, it may be optimal to exercise just before the ex-div dates to capture the dividend. The exam might test this. They'll ask you, okay, for when you calculate for BSM, should this investor is expecting dividends in 2 days? Should I exercise my call so that I'll be able to buy that, receive that share, so I'll qualify for dividend? It's possible. But on non-dividend paying stocks, there's really no point in exercising the option early. And then finally, for delta hedging, remember we said earlier that delta is never constant. It's a mistake to treat delta as constant. The exam actually asks you to actually test to know whether you understand why delta has to change. Delta changes as the spot price changes, and that's what gamma mentions. That's what gamma measures. So a delta hedge has to be continuously balanced. You can't just set it and forget it, because as prices move, the relationship between the price of the underlying and the price of the contract will always change. So the exam might ask you, or maybe might say a conversation between a portfolio manager and an intern, where the intern asks the portfolio manager, "Oh, why do we need to keep adjusting or rebalancing our delta hedge?" Then you will be asked, the person or the portfolio manager will give three statements, and they might ask you which of these statements is correct. You need to understand that a delta hedge has to be continuously balanced because delta changes as the spot price changes. And in order to stay hedged as much as possible, you need to either buy more options or sell more options. Oh yeah, and that's how you delta hedge. That's how you hedge. You buy or sell more options depending on the direction that you are looking for. So, I think that's about all. And then finally, let me see if there's any question. Yeah. Okay. Someone has a question that since delta is negative for long puts, will high gamma be good when we are long puts? Yes. Yes. No, gamma is always good as long as you are long. So, if you're long a put, you're expecting that the price of the stock is going to decline. So you will rather sell it at the exercise price. So you are good if the price, if the price does not exceed, the target you are looking for. Unlike a call where you are looking for you are long. So a call is a bullish position. You are long the stock. You want to buy the stock, but you're hoping that the price in the market will exceed the exercise price of the call option. So you will exercise your call option to buy that stock. Or for a put, you think prices will drop. So you're buying the puts to ensure against a drop in the stock price. So if you are expecting that stock price will going to drop and you buy a put, then a high gamma is positive for that position, because as the price is changing and the value of data is also changing, you need to be very sure. You need to be you need to be in a good position by holding that put. So a gamma is good as long as you are long an option, whether it's a put option or a call option. Okay, and then lastly, just some, let me see, is there anything I need to check through my notes? Okay, I think we're good. So those are the four pillars that just need to consider: valuation, payoffs, profits, hedging mechanics, and protocol parity. So I'll just share some tips, general tips as to valuation. So the there's some between now and then, now and your exam dates, just now is the time to just go through your formulas again, just to make sure that you understand those small nuances that we've discussed, the option Greeks essentially, and note that they will not ask you to calculate any of the Greeks. What they're asking, what they're most likely going to ask for is your understanding of how each of them affects the price or the outcome or the hedge that you've taken on a particular underlying, and just need to review. Now is a good time to review the blue boxes again, because it's literally, I mean, people ask me, oh, should I read the curriculum or should I read this or this other prep provider? I said, anyone you choose is fine. But personally, I remember back then, my level one, when I was reading the first few pages of the curriculum, and and then I saw that the ecosystem or the LES or the curriculum is actually the basis for all the questions that will be set on that day. So I thought to myself, why not just focus on this curriculum? I mean, at least for the remaining part of my preparation. So focusing on the blue boxes, reviewing the practice questions again, debriefing the questions that you didn't get right. Derivatives is very straightforward. Just like mathematics, there are rules. Once you understand the rules, once you know the framework, and once you know how to plug in right numbers into the formulas or into the frameworks, then you'll be good to go. So I'll just do a brief summary of what we've covered so far. Let me just end the slideshow. Yep. So a brief summary of what we've covered so far. Stop share. Number one is that you should understand the impact of each of the Greeks on your portfolio. Number two is that okay, let me just start take from the top. Number one is that there's difference between valuation and pricing. Value and price are the same at initiation at t equal to 0, but as t becomes 1, becomes 2, as time passes, then the value will change with from the price. So you need to understand the difference between the two, and that is covered in the first reading. So going through reading again just to refresh your understanding of those other concepts, revise the questions, the blue boxes, and to make sure you have a very good understanding of difference between the two of them, which I believe you all do, because you covered that in level one, and it's just to build up on that for level two. Always know the question, always check the question whether they're asking to calculate for value or for price. Read the question twice if you need to verify. Then the second thing to consider, we consider is payoff versus profit. So this is when we're talking about options. So if the payoff for a call for an option is different from the profits. So the payoff is usually formula using for a call option, it is maximum of 0, and the spot price minus the exercise price. For a put option is flipped. It's maximum of the exercise price minus the strike price. No, my exercise price minus the underlying price, and 0. But profits is the payoff minus the premium you pay. So that's a very key difference that we need to understand. And of course, I'm sure we are all aware that sometimes in the options will give us the payoff and the profits in as options. A can be a payoff, B can be profits. But because they're asking you for the profits, you need to know exactly what you are picking, and take your time, do not rush. Again, in the question, in the whole total exam, I only come across 5 or 6 or fewer more questions. Just note that I want us, whatever question we see, we get it right by following these key principles. Don't forget to calculate the time value of the future value of the premium. The exam will most likely put an answer where they just deduct the premium completely. But you need to consider time value of money before you get your profits. And then for hedging, So I personally really like hedging question because it is so straightforward. You have a position and you're asked to hedge. First thing to do, what's my position and how do I hedge? You take the exact opposite of the position you have so that you're able to calculate how many contracts you need to buy or short. The first step is to calculate to determine what position should I take to hedge this. What position should I take to hedge my position? If I'm long, then I should be shorting. If I'm short, I should be buying contracts. And then calculate the number of contracts I'm buying or number of contracts I'm selling. For equities, it is the target beta minus the portfolio beta divided by the beta of the futures contract, which is almost often 1 times the value of the portfolio divided by the price of the futures. So that will give you number of contracts to buy or sell. For fixed income, it's the target duration minus portfolio duration divided by the duration of the contract itself times the value contracts divided by the futures duration. So that's how to calculate for hedging. And then lastly is the put call parity. And we said that the fiduciary call has to always equal protective put. That means the call option, the call of the premium paid on the call plus the risk-free borrowing must equal the long stock plus protective puts. So if you calculate that and you see that there's a difference, there's a gap between both of them, then there's an opportunity to make an arbitrage profit. So if you do the calculation, you see that you have to buy, you can either have to buy the long, short the call, or one of those combination of of strategies to take advantage of the mispricing in between those two equivalencies. So lastly, I wish us all the best. And then for formulas, it helps to actually write down the formula, even if you know it's in your head. When you see a question, please write the formula down on your paper. So it's to give you a very clear idea of what you are working with, so that you are able to exactly get the right, plug in the right numbers into the formula you're working with, and I believe we will do very, very well in the upcoming exam. Thank you. Okay, I can see someone's asking I should go back to the protective put slide for a few seconds. Okay, let me just do that now. I didn't see it on time. My apologies. Let me share my screen. Okay. Can you see my screen, Zainab? You asked to see the okay. Oh, not this one. Which one is that? Okay, this one. Okay. Okay, does anyone actually have any question? I thought maybe if anyone has a question, we can just maybe one or two questions before we go. If there are no questions, that's fine. I wish everyone a great preparation. Please rest well before you as you read. Now is not time to do overnight. Please rest well. You need a lot of rest. and a lot of eating. Eat well so that you are well exercised, well energized as you go to write. Okay.
Thank you so much, Mr. Chukwuka, for this section. It was so insightful.
Thank you. Thank you for your time.